Hi everyone, my name is Jessica Cardoza de Lopez, and I'm going to be presenting on the Redwoods National Park. This is a geologic journey, and this isn't just about the geologic story from ancient oceanic rocks. It's actually a lot about active tectonic forces that are still shaping the land today. The Redwoods National Park is located in Northern California. It's about 5.5 hours from Fullerton, and it receives approximately 400,000 visitors each year. The park is most famous for its coastal redwoods. They're some of the tallest trees on earth, but apart from that, it also holds a very rich indigenous and European history. One really interesting fact is that the redwood trees can absorb water from fog through their leaves, and that actually helps create rainfall. Well, what does that do? Rainfall supports the local ecosystem. Here's a view of the misty redwood forests. These trees aren't just drinking fog, they're helping create microclimates. The way redwoods interact with fog makes them crucial for carbon and water cycling in the area, especially during dry months. This natural climate buffering effect is part of what makes them so special. The park lies near the Mendocino Triple Junction, where the Pacific North American and Gorda Plate meet. This is a very active tectonic zone. The Gorda Plate is being subducted under the North American Plate. That's why we see so many folded, uplifted rocks here. The tectonic stress forced deep oceanic sediments onto land, creating complex formations like the Franciscan Complex. Wow. So the rock formations and types. So the dominant rocks in this park are sedimentary, such as sandstone, mudstone. They formed during the Mesozoic era, and these formed when sand, silt, and organic material settled on the seafloor. They were compacted over millions of years, and later on, tectonic activity pushed them upwards. Some rocks, like schists and phyllite, were altered under heat and pressure. What this tells us is that the region experienced both deep burial and intense tectonic stress. Most of these rocks are formed during the Jurassic and Cretaceous periods. Rock ages and fossil evidence. One key structure here is the Grogan Fault, which follows Redwood Creek. The rocks around it are between 100 and 150 million years old. We date them using marine fossils, including diatoms. These are tiny silica-covered algae that are preserved in sedimentary rocks. These fossils help geologists pinpoint the age and environment where the sediments formed, showing that this area was once completely underwater. Although there are no glaciers here today, glaciers during the Pleistocene epoch covered this region. As they advanced and retreated, they carved out valleys and left behind nutrient-rich soils. This was perfect for growing redwoods. Later on, rivers like Redwood Creek and the Smith River cut through the uplifted rock. They carved out valleys and created sediment deposits. So both glaciers and rivers help shape this land. Present-day geologic activity. Today, the region is still geologically active. The plate boundaries near the park produce frequent earthquakes, and uplift continues, changing the landscape slowly over time. Faults like the Grogan Fault are still moving. This tectonic activity isn't just a thing of the past, it's actually ongoing, and it contributes to the rugged terrain, landslides, and stream shifts we see in the park today. Water, fog, and hydrology. One of the most unique features here is the interaction of the water and climate. Redwoods get up to 40% of their water directly from fog. During the dry summer months, fog condensation on their leaves drips down and soaks into the soil. This keeps streams flowing and groundwater levels stable even without rain. This region's floodplains also support fish like salmon. Alluvial fans and coastal change. Because of the steep terrain and heavy rain, the park features alluvial fans. These are found near rivers such as the Smith and Klamath as they exit mountain areas. The coastal line also changes constantly with waves eroding cliffs and shifting sediments along the shore. These are the main sources I used, including the National Park Service, academic studies, and the map of the U.S. Geologic Survey. Thanks so much for listening. I hope this gave you a better understanding of how the Redwoods National Park came to be and why it's still such a dynamic and living landscape today. Take care. Thank you for watching.